Hey, good evening, everyone. I hope all of you are doing well. So, today we are having a very great session and from one of the great community contributors. So, like, before we start with today's session, I'll just give you a quick introduction about this Azure Developer Community, why we are doing this, and what are the things we have in upcoming days. So, hey, I am Rohit. I am from Azure Confirm, and we have been running this Azure Developer Community for the last 6 months. And currently, we are spread across 101 cities in India. And we started this community with the motive of helping each and every people in the country to learn, network, and upskill on different technologies by learning and helping others to learn. So we have many organizers who help us to drive these sessions and help others learn. We also have many great speakers who come here and share their experiences and knowledges as a form of meetup sessions, and also workshop. So today we have one such person who is not only a speaker but also uh, is an organizer who has been recently onboarded as an organizer for the Azure Developer Community. So let us bring Ambaresh on stage. Hey Ambaresh.
Yes. Hello, Rohit. Hello, everybody.
So how are you doing, Ambaresh?
I'm doing very good. Thank you. How is everybody doing?
I hope everybody is
Okay.
enjoying the
Uh-huh.
weekend. It's a
Uh-huh.
Saturday and it's
Uh-huh.
evening. And also on top of that, we have a very great session by you
Hmm.
now.
Yes. Thank you.
So
Thank you.
Ambaresh, if you could tell us something about your session, like what is it going to be about, and something about yourself.
Yes. Yes. I'll share my screen first. Okay.
Sure.
I'll share my screen. Nice. So you are able to see my screen. Okay. So here what we are going to do is that we are going to do some we are going to build a recommendation engine. So what is a recommendation engine? You all of us have been using recommendation engines, like say suppose I'm on Amazon, I'm buying a book, say I'm buying a business book. So what happens when I go there? So Amazon gives me the recommendation, since you have bought this book, maybe the range, please buy Atomic Habits and blah blah blah. So what it is doing, based on my preferences, it is giving me some recommendations. I'm on Flipkart. Since I have bought a, say, a mouse, it is telling me that please buy a mouse pad, a laptop, or a computer cleaner. When you are on Squiggy, since you have, I don't know whether on Squiggy they do this, because you come with pre-filled ideas. So since you have eaten this, these are the recommendations. So recommendation engines are there every part in our lives. So here we will talk of not only using a recommendation engine, we'll build a recommendation engine in just 30 minutes. And what we will do is that we'll build the recommendation engine and we'll explain the internals of it. And then what we will do, the best thing is that it's not, we will take the data set from a Kaggle competition, we'll take it and then we will deploy it in Azure ML. So something like, I am not only building it, but I am deploying it in a production environment. So that's the whole concept. And the idea is that we take it from a competition like this Career Village competition in Kaggle. So what they do um, is that it is a community where students get free personalized career advice from real life professionals. Okay, so this one is something like this. So you go to this site. So it is, if I just bring up my machine, so it is like this. I go to Career Village. Okay, so this is where, so I ask a question, you can sign up, you can ask a question, and what they would do is that they will send this question to a professional who would be able to answer it. Say suppose this question that what technological tools are important in maintenance? Very very difficult question. What maintenance? Is it software? But anyways, if it is a software, what? Oh, it is technology tools. So what it will do, it will send to somebody who knows about computers and so and so. There is one question, pilot after BBA. So this is very interesting, right? So somebody wants to be a pilot and they are wanting to ask questions. So you won't send it to a person like me who is not a pilot. You would send it to somebody like who has been a pilot and can answer it. So what it is doing, like I had bought a book and it is recommending me similar books. So similarly, if I were a professional or a volunteer for these questions, what would happen is that it would recommend me a question which I am associated with. So, so this data set was available in a Kaggle competition. I'll share the link. But what I had done is that I've simplified a little bit. So a little bit about this career village. So in short, what it is saying is that career village needs to be able to send the right questions to the right volunteers. So this competition ran quite long back. Say develop a method to recommend relevant questions to professionals who are most likely to answer them. So what I had done is that I had made the competition problem into a much more simpler problem. So what I would do is that uh, the data set has a number of questions and a number of answers. So question one, answer one, it's already there. Now, what I am trying to do is that suppose I give it a question which is a completely different question, right? Um, and then it would try to find a similar question and it would rank the questions and get top in similar questions. The ranking is done, and then we'll find the answer and display the answer. So the professionals part is out of the picture in my demo, but still it is quite a recommendation engine. And this type of recommendation engines are called content-based recommendation engines. So this is the story. Okay. As for myself, so this is all about the problem that we are going to solve. As for myself, so I am a software professional who has been working in the industry for quite some time, nearly more than 2 decades. But what I love is I love data science. I love competing in competitions, speaking a lot. And so here I am with you in this evening. And thank you if you are listening to this today, this evening. And if you are not listening, maybe listening later, thank you for listening. So this is what is a question and answer recommendation system. It will give a question and will make the recommendations. So this is what we are going to do. So this is one technique. We will use a technique known as word embeddings. But before we go into word embeddings, we must understand one thing. The question is like a sentence, right? Say, I want to be a data scientist. What should I study? I want to be a carpenter. What should I study? So, but computers do not understand text, right? So, what we have to do is that we need to um, convert the sentence into numerals. So how do we do that? There are several techniques, and we'll come to the actual technique that we would be discussing here. The first technique that we are going to see is the one-hot encoding technique. So what does one-hot encoding technique do? What it does, it takes a word, and then what it does is that there are several words in the whole corpus, right? So what it will do, it will put a one there and put all zeros where it is not there. The problem with this approach is that consider that I am giving you thousands and thousands of questions, right? So what will happen is that the matrix that we are building, so you can consider this as a matrix. This matrix will become very, very large, and the amount of information that it will have is very sparse. So as far as performance is concerned, it is not that good. So that's a problem. This is a solution that we can do to convert a sentence into a numeric matrix. That is what it is. So the next technique that we will see is a linear encoding. So what is linear encoding? So what we do is that the sentence has words and each word is given a number. So you see the is given the number 1 and the is also repeated here is 1. So it is 1, 2, 3, 4, 1, 5. So that is the sentence. The problem with this approach is that it is compact, but it has one problem. That means that there is no relation, the contextual meaning of the words is lost. So that is the problem. That there is another technique which is called word embedding. So word embedding, what it does is that this is fun. So word embedding does that it contextualizes the thing so that similar words are together. So that is the fun part. How did they do it? So they trained on various sentences, words, and they found that each word can be represented by a dimensional vector. So it can be n dimensional. So this is a very large matrix. So they have considered a 300 feature vector for each word. So to see the beauty of this, let's see an example. I should have got this thing open. Let me see. Yes, I have got it open. Just bear with me. Hopefully it opens. So we'll show an example of word embeddings. So what word embeddings is that, okay, before we go into word embeddings, let me explain to you another concept. So you understand that this is a word embedding. Hmm. Let me explain it while this thing comes up. So here what is happening is that we will use a library called Spacey, which is an industrial strength library for natural language processing. Okay. So what does this Spacey do? This Spacey has several vectors. Okay. These vectors, what would happen is that, so it has got around 684,000 words in it. So I divided by 1 by e to the power 3, and each word is a 300 dimensional vector. So that means one word is equal to a 300 dimensional vector. How did we get this? So this is trained, this we are training, this has been trained by say Google, or so Google has done some this word embedding vector, and Facebook has done, so there are different names for it. So what it does is that, say suppose I will demonstrate this by, say suppose you have a word called queen, right? So this queen has, you see, when I do an LNP of the queen, I get a vector. So what is the shape of the vector? That is 300. Now I said that similar words are together. That similar thing, what do you mean by similarity? Now, yes, I'm going to explain to you another very important concept called cosine similarity, which you perhaps know, but still I'm going to explain, and it is a very easy concept. So most of us know that a vector can be represented by, if it is a two-dimensional vector, it is represented by 2 points. If it is a three-dimensional vector, we can represent it by 3 points. If it is, you see, that is 3 points. But if it is a n-dimensional vector, that means a 4-dimensional vector, now our human mind cannot visualize it, but it will have 4 points. If it is a 5-dimensional, 5 points. So you get the concept, right? So if it's a 300-dimensional vector, it will have 300 points. We cannot draw it, but you can imagine it. Now, what happens that, how is a vector similar? Now, you see that this is called the cosine. The cosine part is very similar. Like in your 9, 10 standard, you have run that the cosine between cos theta, if it is cos 0, then it is 1. That means the vectors are very similar to each other. if it is cos 90, that means it is orthogonal. What happens is that the cosine is 0. That means they are not very quite dissimilar. So there is a very fancy way of saying this in maths, but I just want to give you a glimpse of it. So cosine cos theta, the similarity is a vector dot b vector by the L2 norm multiplied by the another L2 norm of the vector, which is a very fancy way of saying like a dot b, meaning this each element is multiplied by its own 1 star 1, 1 star 0, 1 star 0, 1 star 1, a dot b. And AL2 norm is another fancy way of saying that a dot a 1 star 1, 0 star 0, 0 star 0, 1 star 1, and then the square root. You see, this is the mathematical notation of it. And then what we do is that a dot b by AL2 norm start BL2 norm. Okay. Now, what would happen is that, so this is a very elaborate way. You don't have to go into depths because we'll have a very nice function for all these things. But say suppose you want to implement it yourself. Say suppose you want to implement tomorrow a recommendation engine, say in a very fast language, say Go. You don't have this library which Python is giving you, or Rust. Then you can apply this concept. It is a very simple concept. So this is what some, meaning if you are not into all these maths, but still as a software engineer, you can understand that this is very simple. So this is what is a cosine similarity. Now let's go back to the problem. So the problem was that I said before that how queen is similar to king. So the cosine similarity is 0.72. Queen and mother is 0.44. Queen and princess is 0.65. So what are we noticing? We are noticing that the queen and the king, the contextuality, the similarity is more, and then comes a princess, and then the mother is slightly less. So that is what it is. Now let's consider another example, some fun. So now I'm not considering a word, it is a sentence, like our sentence, a question answer. So this one I'm saying, NLP, give me this. I'm a software consultant. Hey me data guy, hey me plumber. So you see what is the shape? The shape is still 300. How come? Because what is happening is that this every word is 300. So what they do is that they take the average of the values of all these 300 vectors, and still it becomes 300. So it's not adding up. Not that if there are say 1, 2, 3, 4, 5 words, it will be 500, 300 into 5. It is just doing an average. So that's the thing. So this is a cosine similarity. And yeah. So here the cosine similarity of x1 and x2 is say 0.73. The x1 and x3 is 0.64. So that these two sentences, like a software consultant and a data guy, is more similar than a software consultant and a plumber. More fun. So what I did was that I chose some fancy words: Pepsi, Coke, Sprite, chips, potato chips, and teacher. So if you do a Pepsi Coke, it is 0.65. Pepsi Sprite, note it is 0.39. It's not similar much. Pepsi chips, all the more less, 0.24. Pepsi teacher, completely different, no, practically no similarity, minus 0.009. Pepsi potato chips 0.29, which is slightly higher than Pepsi chips. So you get the fun idea, right? That I am now building context into the words. So this is what we are going to use. So this is a concept of word embeddings, and I am going to use it in my recommendation engine. So I'll just see if there are questions. Okay, not questions till now. Okay, some good comments. Thank you, Vijay, for the good comments. Okay, let me continue. Okay, now this is the Azure ML part. Okay, but before I go to the Azure ML part, I will explain the concept that is the crux of the thing. So what it is that we'll explain first our code. So the code is, what happens is that I read these files, questions, professionals, and answers. These are some CSV files which are there. So what happens is that, so if I can just go here, Azure ML, the data, it is all here. If I open it, okay, so this is what it is. So it has the questions, and this is questions title. Okay, okay, maybe column width, maybe 100. This is a questions body. So this you get it right. This is a questions, question ID, and the question body. Okay, so I'm going to use this, and then there is the answers. So let it open. In the meantime, okay, it has opened. So it has the answers. It has okay, it has got the answer, answer question ID, and the answers body. So this is how it is related. So what I have done is that there was no need for the professionals. Anyway, what I have done is that I have merged all these things. So this is just a merging so that I can create a data set of professional answers and questions. So what I do is that I do a is.na. I remove the things that which are not null, actually not blank. Then I what do, I create a question answer set, and I do the questions and the questions body. So this is my questions, full questions, all the questions that are there. Okay, then what I do is that I have done I have done a clean text. What does clean text do? It just removes punctuation, it makes it lower, all these things, and I do a cleaning of the text. Then what I do is that what I was saying previously. For each question, what I am doing is that I am creating a 300 dimensional vector. So here, this guy is creating a 300 dimensional vector, and I am dumping it into a pickle file. You will see why I am dumping it into a pickle file. So this is about the training. So we'll explain once again. So let's understand. So for each question out here, I am having a 300 dimensional vector. And then what I am going to do is that during the inference, when a question comes in, what I'm going to do is that, say a new question comes in, what I'm going to do is that for the question, say suppose I have a question like this one, this guy. Where is my question? I want to be a data scientist. What should I study? So this question comes in. So what do I do in this question is that for each question, for the question, I will create a 300 dimensional vector. Now you can imagine, right? So I have got a whole set of questions that are with me, which is all 300 dimensional vectors. And now I have a new question, which is also a 300 dimensional vector. Now I go through a loop, and what I do is one simple statement out here, q new, and with all the spacey questions which I have got, which I have loaded here, and then I do a cosine similarity. And so for each question, I would do with a new question a cosine similarity, and then I would rank it and then present it to the um, user. So this is what is going on. But before that, what I will do is that I will explain it once more. So here what it is doing is that, where is it? So here I am getting the response from here, and then for each question I am ranking it, ranking the similar ones, and then I am taking the first one, which is the best ranked one, and then the other ranked ones. That's fine. what I will do is that this is a basic concept that is there. So what I will do is that I will go and start from the scratch of how we are deploying it in Azure ML. Okay, so we'll come back again to this and explain step by step. But the basic idea, what I want to tell you is that it is very similar to the one that we explained out here with this vector. So this is all the question set. Question 1, question 2, question 3, question 4, question 5. I have a 300 dimension, and this is my new guy which is coming in, which is a q new, and for each one I am calculating the cosine. And what happens, I have the cosine and then I sort it and I put the one which is the highest cosine. The closer it is to 1, that is the most similar question. And that question, for that question, I also have the answer. So I will give the answer to the user, the questions which are similar together. We'll explain it with an example. So that's fine if you are not getting at this point, because I will again explain it with an example. So let's go and see how we will deploy it in Azure ML. So, so this is the concept that is the core, the heart of my modeling. Now, the next comes is that now I have built a very fancy model, right? But I have to make it available for production. So what I do is that I will show you a complete workflow here. So what in Azure ML is there, you have to create a workspace. So now we are in Azure ML, we create a workspace out here, which is a home for every all of our experiments. So this is a workspace. It has got experiments, it has got models, it has got data stores and everything. Okay, so this is a home. We are creating the home here first. And then what we are going to do is that we are uploading all these files which are there into a data store, into a default data store. Okay, what is the default data store? So what happens is that when you create a workspace, what happens is that it comes with certain data stores. And these data stores, they point to an Azure blob container. Okay, so once you go down here, if you click on this, after I execute this, what will happen is that I am pushing the data for my all these things, all these data files into the container. So the container is out here. You see, this is the files that are there. These are the files which I am being put out here, so that I can do the modeling. Okay. Now what I do is that I create the training folder just for my script. And then what I do is that I create the compute cluster. What is the compute cluster? So in my machine, if I had run it, I would use the CPU of the machine, right? So in Azure, I have to allocate a machine for that. And in this way, the Azure ML gives me the opportunity to create a compute in Azure. And I am using a standard D2V2. So once I execute this, I have already created all these things because it takes a lot of time. So where am I seeing it? You can see if you just execute all this code, it is all out here in the compute. If you see the compute cluster, the CPU cluster is the one which is created. Here is where the code will run. Then what happens is that I create the training script. This is what we have explained. So this is a training script, and this is where this is in my machine. So this is a training script which is there. Then I create the environment. Why do I have to create the environment? Because what happens is that this script requires certain libraries. So it requires Spacey, it requires scikit-learn, it requires pandas. So this is what the environment is doing. So this is the libraries which are required in this environment. And then I registered the environment. And then what I do is that I create an estimator. What is an estimator? So I have got the training script, I have got the script params, which is a data folder, the compute target, the register environment, and the entry and the training script. All this is combined together. Since now you see that there is a training script, there is a compute target, there is an environment, there is a source directory. All this is compute, all this is combined in the estimator. Then what you do is that you create an experiment. What happens is that you can do many experiments out here. So this is what you are doing, is that you are creating an experiment. So we can see the experiment out here also. You can see the experiment out here. You create an experiment, and then once you submit, you can see you are submitting the run. So this is a run. It takes quite some time. It takes 15 minutes to do all these things. Okay. So I've run it earlier. And then what I do is that I register the model. So what I am doing is that this question answer that we spoke, right, the 300 dimensional vector that we are creating, for each of the questions we want to store it in our workspace. So we are storing it in our workspace, and we are storing it as a model. So where are we storing it? If you go to the models, you can see the model is saved here. This is the models that is there, and you see it is tied to the experiment run, and it is tied to the run ID. So this is the run part of it, and we are registering it. So till now, what we have covered, if I summarize, is that I have created a workspace, a home for everything. I have uploaded the data. I have created the training script. I have created the compute cluster, and I have created an environment where these things would run, because the libraries are required for this. And then I register the environment in the workspace. All this is done, and then I create the estimator, which combines the training script, the compute target, the registered environment, and the train, and all of this together. And then I submit the experiment. So till now, what we have done is that we have created the 300 dimensional vectors for the questions and saved it, and it is all done in Azure. It is not in my local machine. So everything is production stage. Now what the next step we are going to do is to send a question, right? And this question, we will send it. But where will we send it? We need to deploy, right? So now we will go into the deployment part of it. But before that, I will take a pause and see if there are any questions. Okay. Thank you. So, okay, that's fine. So, I'm not seeing any questions. Okay. What I will do is that we will again pause for questions after some time. Now what we do is that, now say suppose you have done a brilliant job in doing this recommendation system. Now you want to expose it in a website, and that website has some backend services, but that backend service needs to somewhere. What you would do now in this cloud native world, you will deploy it to some Kubernetes service. Now what I'll do is that I will deploy the model in the Kubernetes service. So this is a first is the inference script. So the inference script, it has got two parts, init and the run. So what is the init? It is getting the model from the registry, that is from the model registry. It is getting this model from this registry out here. And then what it is doing is that when I'm running it, it is loading all the questions. And then I had said earlier, right, this new question out here, it is then converted into a 3-dimensional vector, and then I'm doing a cosine similarity with each of the 300 dimensional vectors of each of the questions. So if I have around 10,000 questions, so I will have now 10,000 results. Okay, sorry, excuse me. So this is what it is doing, and it is showing the result out here. Now what we do is that we create the dependencies for the inference script, that is the environment. So this is what we are doing. We create the inference configuration, that is the combining um, the training code and the environment file together. So this is what we are doing here. And then what we do is that this takes a lot of time. We are creating the inference cluster, and this cluster is a Kubernetes cluster. So we are deploying it into the Kubernetes cluster. So this is a deployment which is happening with the model that is there, and we are deploying the model into the Kubernetes cluster. So you can see the Kubernetes cluster which is deployed out here. If I go to compute, now this is the inference cluster. This is the AKS cluster which we have created. And if you go to the cluster name, and if you're familiar with Kubernetes, it creates its own cluster. And what it will do is that we will expose this model as a service. So if you see service and ingresses, you see Reco Service 3. So this is what is we have deployed, a Reco Service 3, which we have deployed. And once we deploy it, what we will do is that we will get a scoring URI. This is the service URI that we are getting. So if I go down here into the cluster, if I go down here, I can see that this is the endpoint 10.244.01.5001. Let's see whether this is the one or not. No, this is not the one. Maybe some other place. If I go back to the Reco Service 3, I think I'm not finding which one is this. Okay, we'll find out later what this is. Okay, here's it. Sorry. So this one is 52.154.167.21. So this is the one, and I guess this would be the one. Yes. So this is the one which is the endpoint which is shown here. And now what happens is that now I have the cluster here. Now what I want to do is that I want to now send all the questions. So now I sent a question. I want to be a data scientist. What should I study? So when I'm sending the question, I pass it off as a JSON. In the request headers, I have to pass the primary key of this service. That is some key that I have to pass. I'm passing it, and I'm getting it is as 200. Now, what would happen is that in the results, we are giving the indices, we are giving the cosine similarity values, right? So now what we do is that we sort the results, the result that we have got. These are the results that we have got, right? And then we sort the results and find out the indexes of the questions. Now, once we have the indexes of the questions, what we are going to do is that we are going to get the answers of these similar matching questions. So here, I want to be a data scientist. What should I study? What happens is that my best answer is this one. So this I have found a similar question and I have got the answer. So it shows that I am not a data scientist, but I think I can give you some advice on this, some programming languages and tutorials. The second best answer is about, they're saying about to go for algorithm videos and use cases and all these things. The third best answer is about some computer engineer and all these type of things. So this is more or less what it is happening. So it is finding the best answers and it is showing it back to you. So in this way, we can create a recommendation engine. We can have a service which is deployed in Azure Kubernetes service, and we can deploy them, and we can see that how you can use. So now you can build any UI. You can build a React.js app. UI, you can build a Streamlit UI, do whatever. And then you can call this service and you can get all these recommendations. So this is all about it. I will take a pause and I will see if there are any more questions. I can't see the comment section. Okay. So this is the comment. These are the answers. These are the answers that are here. These are the answers which are coming in. If that answers your question. Okay. Oh, please drop your questions in the comment section. Okay. Okay. I was thinking about the other thing. Can you share how we get to know about Python libraries that help to integrate Azure ML with Python? Sure. So what we are doing is that, so the Python libraries which are used here is Azure ML.core. You can use Azure ML.core. So I'm using these Python libraries like Azure ML.core, and that is what I'm using mostly. If you see Azure ML.core conda dependencies. Oh, another good thing is that I will drop, so all this code, everything is here. If you go to my GitHub, GitHub, Ambarish G. So this is the GitHub link, and this is a recommendation engine and ML series which I had given. Okay. Now here for you, this is session 4 and session 5. So there is a blog also for this. So everything is written in blog format, and there is a code files are also given. All the code that I have shown is also given. So let me just put it in the comment section. Where will I put it? Okay. Okay. I cannot. Okay. So this, if you are seeing it here, this is the thing, Ambarish G Azure ML. So this is the one that you can see. Let me go back. I think there are some very good questions. Okay, can you please explain the deployment and the service? Okay, very okay. I will explain that again. If we want to retrain the model and update the already trained model, how do we do it? So what do we do is that you don't have to do anything much. So what you have to do is that you can mm, uh, where is the code? So what you have to do is that you don't have to create all these things. Maybe you have to write some code if it's already there. You don't have to do all these things. So you don't have to create the computing cluster. You just have to run from this step. From this step, and maybe this also is not required to run. You can run it. This also not required to run. What you need to do is to change the code out here for whatever, if you want to change the code. And then what you have to do is just submit the experiment, it will run, and then you again register the model. So your model will come up here. Your model will come up, where is that? Your models will come up here. It will be version 2. Once you register, this will become version 2, and you can actually, if you don't put any version number, I think it will get the latest model and you can use it. So that's how you will retrain it. So that is the thing that is there. Okay. Okay. Can you explain this deployment and the service creation part again? Sure. So we have created all the questions, a 300 dimensional vector, and now we want to deploy it. So how we deploy it? First, we create the inference script. So the inference script is composed of only two parts: the init and the run. What is in the init? We are loading the specie questions model, which is the 300 question vector that is there. So if I just remove all these unnecessary things, so this model I am loading it. So that is the part in the init when the service is loaded. And then what I am doing is I am passing in the raw data in the form, I am passing in the raw data. Then I am I am loading the questions. Okay. Then what I am doing is that, Mm. So this is a model path. The model path is a model path of the questions. So I'm loading it here. And then when this new question is coming up, I'm doing a cosine similarity. So what would happen is that if I have 10,000, 20,000 questions, what would happen is that for each question, there would be a cosine similarity with this new question. So if it is 20,000 questions, I will have a 20,000 uh, uh, 20,000 elements in this result array. So it is like 0.99, 0.97, and maybe 0.7, 0.8, and maybe 0, 0.01. So all these arrays would be there for 20,000 questions. If I pass 20,000 elements would be there. Then what I do is that create the dependencies. Dependencies is what? It is the all the libraries that I require in the inference script that would be there. And then I create the inference configuration. This is the inference configuration that I would have. And then what I would do is that I would create an inference cluster. What is and why we are creating an inference cluster? Because you have created a fantastic model. Everybody in the world is interested about it, but you want to have a scalable deployment of your cluster. We are in a cloud native world, so we'll deploy it in AKS cluster. So this is what the AKS cluster is doing. We are deploying it here, and we are deploying it into this AKS cluster. So if I go to my workspace, if I go to compute, once I deploy it in this inference cluster, this is the AKS cluster. So I go out here in the AKS cluster. And as you know, when you deploy in the AKS cluster and you want to expose it as a service, what would happen is that you will expose it as a load balancer service. So this service is exposed is as an external IP out here. So you see, this is the external IP that we are getting. So this external IP we are getting out here. So once this is done, we can now use it in our predictions. So we get the service keys, that is the primary key and the secondary key. We take the question, x new is a question. We convert the array, that is this array, into a JSON. We do the request headers. The request headers is a JSON header with the primary key, which is the key, the secret. And then we post it to the endpoint. The endpoint is this endpoint of the Kubernetes cluster. And we are with this, and then we get the response, and the result, as I have said, what is the result? It is the result is 0.99. All these values are there, but this will not help us. We have to know the index of the question, right? So what we do is that we sort the questions uh, in an ascending order, and from the last we take the minus 10, that means the 10 best questions, and get the index of the questions. Once I get the index of the questions, in this array we have the questions and answers. So from their index of the question, I get the answer. So this is the first best answer, this is the second best answer, and this is the third best answer. So this is how it is done. Okay, thank you, Vijay. Yes, very good questions. So um, so again, I want to show you something interesting, is that another thing that I have been doing.
Looks like Ambaresh got dropped out, so we'll just wait for some time. He will join back. Meanwhile, if you have any questions, you can uh, drop them in the comment box.
Hello.
Hey,
Oh,
Amresh.
sorry. It somehow it went away. Oh, I
No
keep
problem, no problem.
saying
It happens.
sorry about that. Sorry
Not a
about that.
problem.
Yes, video share screen. I tried to do something and then it went away. Share screen. Yes. So I am back here. So here, what I am going to show you is that. So as part of the community, I've started an YouTube channel. So this channel, hope you guys are able to hear me, right? Yes.
Yes, Amresh.
So this one, this YouTube channel, where is this? There are a couple of playlists out here. One is an intro to deep learning, Docker, Kubernetes, ACI, and AKS. So what it is that I've started with deep learning, and then I went into deploying a deep learning model into Azure container instance and Azure Kubernetes instance. So 21 videos. It follows a Kaggle learn course to some extent, and then it goes on to deploying into Azure and everything. So please, if you are interested, it is quite extensive, and it is around 14 videos that I see. No, 21 videos. 21 videos with exercises and everything. Please do see if that interests you. If you're not interested into, you can go for a Docker and Kubernetes playlist, which I'm. There are 6 videos. This is another one, and another one is this one, which is a DP 100 Azure Data Scientist playlist. So this is not yet complete. There are 4 videos, but this is a full course of DP100 as your data scientist. Everything what is in that MS Learn course, I'm doing the practicals, and if you are aiming for these exams, I think this will be very helpful for you, because I passed it, and more so because I'm doing it again. So it also helps me to refresh my ideas, and also it will help you, because since I've given the exam, so I'm explaining the concepts very clearly to you. So please do have a watch if you are aiming for. If you don't want to give the cert also, go ahead and see these lectures, because we are going deep into Azure ML. So that's it from my side. Yes, so these are some of the learning materials that are there. Yes, it is all recorded. And all these are recorded in the Azure YouTube channel, so you can watch it later. More questions? Happy to take. We have 6 more minutes. Yes.
So, guys, if you have any questions, you can you can make a comment so that
Hmm.
Amberesh can answer them.
Yes.
Or else, Amberesh, like if there are no more questions, what we can do, if
Hmm.
people come back and like pose their questions, we'll be sharing you the live URL with you. So whenever you
Yes.
put them, you
Yes.
can answer them offline.
Yes, yes, yes. Live URL, please. What we'll do is that I will post also my link of that playlist and everything,
Sure.
and then people can watch, and I'm sure you will enjoy this thing. And this one, I don't know whether it went away or not. Uh, the all of it is available out here as code. All data, everything is available in this GitHub repo. The sessions 4 and 5, this has got the code, and all the blogs also are there. So what we will do is that, oh my God, this is coming up. So all these things will, um, this GitHub repo link also I will share with you, so you can, if you like it, please go ahead and star fork it, and so this is all there out for you. It also has the YouTube channel link, so everything's there. Okay, so
So I think that would be all, Amberesh.
yes,
And
yes,
thank you so much for joining us today.
hmm,
It was a really
yes,
nice session, and I hope people have liked it and people would have learned something new today. And as Amberesh mentioned, we'll be sharing those GitHub repo and the other learning resources with you after the session. And in case if you haven't joined the Azure Developer Community, I would request you to join your nearby Azure community so that you can receive the post event newsletter and all the emails and all the upcoming updates as well.
yes.
So thank you so much, Amberesh, for joining us, and we hope we'll be having you in our future meetups as well. And there are
Sure.
so much to learn from you, and people would definitely love to have you again as a speaker in the community.
Yes, thank you, Rohit, for also having me, and thank you everyone who is listening live and for asking very good questions. And it also helps me to learn if you ask questions. Moreover, apart from this talk, I am also learning mm, while giving these talks. So, thank
Yes,
you so much, everybody.
yes, definitely. Like the learning never ends, so we all keep on learning with experiences. Yeah. Thank you so much, Amberesh, and thank you everyone for joining us today.